Welcome to this Azure Kubernetes Service on Azure Stack HCI deployment and installation internal session. My name is Mike Kostersitz. I'm a principal PM lead on the Azure Kubernetes Services on-premises team, and I will walk you through a typical deployment of Azure Kubernetes Services on Azure Stack HCI. While I'm doing this, I'm going to draw out all the components on the whiteboard, and I'm going to explain what each of them do, what information you need to actually configure it right, and to get it managed and connected to Azure. At the end, we will have a 4-node Azure Stack HCI cluster that will be connected to Azure Arc. We will have a deployed AKS service on it that will have an Azure connection and a target cluster and an application running on it. So let's get started. The first thing we need, of course, to get started with this is hardware. So where do you get this hardware from? Azure Stack HCI is a certified set of systems that are listed in the Azure Stack HCI catalog. And first we need 4 nodes. We got node 2. And we're going to create a 4-node cluster for simplicity. But in reality, you can have up to 16 depending on the hardware you're buying. So the second thing we need is a little bit of storage underneath here. And I'm not going to go into more detail on storage. But the storage will be used to actually configure, to store the configuration, the virtual hard drives, and also your application storage for the things that you actually run in Kubernetes. So the other thing that we need right here is a network. And because without network, those computers cannot talk to each other. So we got a network. So the network is going to be our underlying network that will connect to the internet, it will connect to the Active Directory, and so on and so forth. So once we got our hardware racked and installed, and the base OS installed on that, what most customers do after this, they join it to Active Directory. So let's have a little Active Directory here. And I'll just put one DC just for symbolic. And this is our Active Directory and our domain controller. All 4 nodes are now joined to the Active Directory. And customers and your operations team can actually manage those. All right, so now that our 4 nodes are domain joined and we're all set up, the next thing we need to do, we need to establish internet connectivity so we can download all the bits and pieces we need to deploy Azure Kubernetes Services on Azure Stack HCI. So let's put an internet here. And we'll have a proxy server sometimes, but sometimes we don't. So if you don't have one, much easier to deploy. If you have one, we need to know the configuration of the proxy server. So we got all that in place. So the next step that will have to happen is that we need to enable failover clustering on HCI. So we deploy, just like we would for virtualized workloads, we put failover clustering on top of that. And this layer will take care of making sure that our virtual machines that we deploy for AKS are highly available and get distributed across the 4 nodes appropriately and run in a high available manner. So once we got that, so now we are ready to actually start looking at Azure Kubernetes Services and how to deploy it. So what is Azure Kubernetes Services on Azure Stack HCI? It is a cousin of AKS in Azure in the cloud, and it is a on-premises deployment of a managed Kubernetes cluster. This managed Kubernetes cluster will allow you to deploy as many target clusters as your hardware can take, obviously, and as many worker nodes as your hardware can take. We are using, like AKS in Azure, we are using Linux for the control planes. In this case, the Mariner, Microsoft's own Linux distro, is being used for the control plane and Linux worker nodes as the host operating system. And we also support Windows. We also support a set of CNIs, which are the network interfaces in Kubernetes, as well as load balancing, application deployment, CI/CD integration, and it is all connected to Azure through Azure Arc, where you can then use Azure Monitor, Azure Defender, and other services to manage and monitor your cluster. A colleague of mine, Abhilasha, at the end of this presentation will walk us through a demo how to manage what we have deployed when we're going. So let's get started on AKS. So a few things we need for AKS to deploy. So the first thing we will need is an IP address our IP addresses. So the IP addresses that we need here is for the Kubernetes nodes and for the VIP pool, which is the virtual IP pool that's used for Kubernetes services that your applications actually communicate through. So once we have that defined, we can get those in two ways. One is DHCP, and the other one is static. So DHCP is much simpler to use, but it also has its limitations because IP addresses can be used from something else or from something else deployed in the network, and you'll run out of IP address space. Static is much more controlled deployed, but it's more configuration. So it's a thing you have to weigh. And you can also mix and match inside. So you can have your AKS host deployed with DHCP, but all your target clusters with static IP. Well, we'll get to that afterwards. So once we have determined all the IP address spaces that we need, we can actually start deploying. So the one thing that we need for that is a core decision to make. Do we do Windows Admin Center? So here's our admin user. Or do we do PowerShell? To deploy AKS HCI. Both options are valid. Windows Admin Center is slightly more simpler because it takes a lot of defaults and it's like clicking through a setup wizard, whereas PowerShell gives you much more flexibility, but then it also requires a little bit more knowledge of the internals. So in our case, it really doesn't matter because in the end, once you've provided the information, Windows Admin Center is going to call PowerShell with the information that you have provided. So now that we have decided we're going to use Windows Admin Center or PowerShell, we can actually start deploying and installing the components needed to start the deployment. So one of them is the PowerShell modules. They come out of the PowerShell gallery, which lives on the internet. And it hosts our public packages about the modules. There's 3 modules that get downloaded. One is the Microsoft Online Cloud, the mock module. There's a KVA, and we'll get all to that. KVA module, there's an AKS HCI module. And these modules actually together orchestrate installation and management of AKS on Azure Stack HCI. So the other thing we need access to a service in a Microsoft service, which is called SFS, which is the streaming file service. This service hosts all the components that we download as part of the installation of AKS. The VHD images, the binaries we need for the agents, and we'll get to those. All the control planes, everything is get downloaded from SFS. So once we got that, there's a third thing we need, and that's ACR, which is the Azure Container Registry. The Azure Container Registry hosts all the Kubernetes containers that run inside AKS on Azure Stack HCI. So those 3 things we need access to, and once we got that, we can actually get started. So we have all our information over here, and we know that we're going to use PowerShell, which makes no difference for Windows Admin Center, which also calls PowerShell when you are starting the installation. So the first thing that will happen is we will download all the bits and pieces that we need to start the deployment, which is VM images for the control plane, for the binaries for the agents, etc. So they get dropped on the first node or the node you're connected to. So I just call this downloads. And so the downloads folder, this is where all this stuff gets stored temporarily. It gets distributed afterwards, but right now it just gets dropped here. So now that we have downloaded all the bits and pieces that we need to deploy AKS on HCI, the first thing we want to deploy is a component called Node Agent. The Node Agent goes on every single physical node. So we have one here, we have one here, we have one here, and one over here. So the node agents are the interfaces to the underlying hardware platform. So the underlying hardware, so what they're doing is they are configuring virtual machines, setting up virtual networking, storage, and all the bits and pieces that we need to actually get the virtual machines that are AKS on Azure Stack HCI to run. So once we got that deployed, the next step is to actually bring the Cloud Agent in. The Cloud Agent is a generic cluster service, and it goes right here. So the Cloud Agent now needs an IP address because it's going to potentially move around between those 4 nodes. It actually needs an IP address that can float. So that generic cluster service will get an IP address out of that VIP pool. So I'm just going to mark one here and put the CA here. So this is the first IP address out of the VIP pool that you specified that gets consumed. So once the Cloud Agent is deployed, now we have all the infrastructure in place to create and configure virtual machines. So the first virtual machine that we're going to create is the KVA. The KVA is a virtual machine running Mariner Linux. The Mariner Linux hosts a Kubernetes cluster, and that Kubernetes cluster has all the cluster API and operators, custom resource definitions for target clusters, all those things inside, pre-configured. So when that spins up, we now have a cluster, a Kubernetes cluster running that it can also create other clusters. So the 2 things that this one consumes is it consumes a VIP for the API server, and I'm going to talk about that in a little bit, and a Kubernetes IP. So the second IP address that gets consumed out of the VIP pool here is the API server for the KVA. And then the first one of the K8's nodes addresses is for the KVA. So that also gets consumed. So when you're defining your IP spaces, a couple of things to keep in mind is that no matter if DHCP or static, you need as many IP addresses for nodes as you're planning to deploy. So for KVA, we only need 1, but then there's an update scenario where we spin up a second KVA with a newer version that will consume a second IP. So make sure that you have at least 3 or 4 IP addresses in your node pool, in your Kubernetes node pool. And then for the VIP pool, you need 1 for the API server, which is this one here, and you need 1 for the Cloud Agent. And so these 2 addresses float, and so when you build up the second KVA, it actually is accessible through the same VIP. And that also, the VIP allows us to actually move the KVA using failover clustering from one physical node to the other. The other thing that the KVA has built in is a load balancer, which exposes that VIP, and that is a kube VIP load balancer running on Kubernetes. Previously, in earlier versions, we had HA proxy, which spun up a second VM next to that, consuming more resources. We have collapsed it into one VM, and so now we have that. A lot of customers are asking us, actually, what about scale? Because right now, our documentation says you can have 4 HCI nodes. Technically, you can scale up to 16, depending on the HCI hardware you purchase. But we have not tested all those iterations and all those implementations yet. So for now, 4 is the documented limit. We have customers running with 6 and with 8 as well. The difference is when you're growing your cluster, you also need to grow your KVA. So when you do your install AKS HCI, either through WAC or through PowerShell, make sure you specify an adequately sized control plane VM size. Right, by default, it's 8 gigs with 4 cores. And if you want to go for 8 nodes, you'll probably go with 16 gigs and 8 cores to just be safe so that it can manage all the target clusters you will create. So once we got the KVA up and running and the VIP and Kubernetes IPs assigned, we now can actually start building our target clusters. The target cluster in AKS HCI is the component that runs our application. So that one is the cluster that gets used by the user, by the developer team, by the application hosting team, etc. So now when we want to do that, the first thing we need to do is we need to define a couple of things. They're pretty much the same as we have defined for the KVA. We need to define an IP pool for the KS nodes. We need to define a VIP pool. We need to decide if it's DHCP or static. And the next thing we need to actually define and configure is which CNI to use. And there's 2 options here, Calico and Flannel. If you know AKS in Azure, there's a couple of other options. There's KubeIP, and there's a bunch of others that we can use. But For now, AKS HCI supports Calico and Flannel, whereas Calico is the default. So if you don't specify one, we go with Calico. What's the benefit of going with Calico? It brings in network policies that allow you to restrict traffic between pods and applications on a not only IP base, but by fully qualified domain names, by IP ranges, by ports, by a lot of different things that default or standard Kubernetes policies won't allow you. And Flannel is a very simple overlay CNI. So once we got the CNI decided, and I would suggest go with Calico for our deployment, we're gonna do that. And the next thing we need to define here is, do we need proxy settings? And if we need proxy settings because we configure it down here, then we need proxy settings also for the target cluster. What happens with those proxy settings is that in each worker node we deploy, those settings get imported as the worker node spins up. And so you define the proxy settings at the start. We have right now no way to actually update those once the cluster's running. So it gets a little bit more complicated to manage if they have to change. We support proxy authentication, proxy with no authentication, with basic, with NTLM and Kerberos authentication, as well as using certificates. And you can pass a trusted certificate path in the proxy settings, and that will configure the certificate respectively. So what we're going to do now is we are going to deploy our target cluster. And the first piece from the target cluster that gets deployed is the control plane. By default, we deploy one VM for the control plane. So that gets one K8s AP, and it does get one VIP. So one address out of the VIP pool. But unlike the KVA, we can actually scale the control plane like we do in Kubernetes. We can say, I want to have three control planes. So I just specify I want to have three, and we end up with 3 control planes deployed across the 4 physical nodes. So once the control plane's up and running, the next component that gets deployed here is the load balancer. And that, in this case, in the case of the target cluster, currently is HA proxy. So for HA proxy, we actually define a predefined VM size, and you can also change that, but the default is good for up to about 300 services, so you should be, in most cases, good with the default size. That HA proxy is the owner of the VIP pool that you have defined, so that basically owns the VIP pool. So all the services, besides the API server, which lives down here, is going to be hosted by HA proxy here. So this one's going to expose all your Kubernetes services. So now we have our control plane running. We can actually go in and start thinking about our workloads. Is it a Linux workload? Is it a Windows workload? Is it a mixed workload? And we can actually define our node pools. And for the node pools, to deploy those, we can choose between Linux and Windows or a combination of thereof. We can have multiple node pools in a cluster. So for our purposes, we'll deploy a Linux node pool with 2 nodes, and we'll deploy a Windows node pool with 2 nodes. So now we have that, and so we have a place where we can run our application. So once those node pools are spun up, they will consume Kubernetes IP addresses, obviously, because there's 1, 2, 3, 4 in here. So for update purposes, make sure you actually configure your pool large enough so that when we're upgrading, we can do a rolling upgrade with those. And I'm going to talk a little bit about the rolling upgrade towards the end of the presentation. So we need more IP addresses than the ones we count here. So the last thing we're going to do is we will deploy an application. And there's 2 things we need to do to deploy an application. First, we need to get our credentials so that we can actually connect to the cluster. So once we do get AKS HCI credential, the credentials necessary to connect to the cluster get merged into a kubeconfig file. And the last thing we can do is we'll create a YAML file which defines our deployment. it says this is the container you want to deploy, this is the service you want to expose, and all those other things that you need to actually deploy an application. And then we can do a kubectl apply -f myapp.yaml. And that's the file we created here. So what will happen there is that we will create and let me zoom out that Linux node because this is going to be a Linux application. So here is my Linux node 1 or 2 in this case. And that will hold my application. So the application will run in a pod. And that's my app. And my app will consume, because we defined a service, it will consume a VIP out of the VIP pool. And through that VIP address, it's now reachable. Usually in customer deployments, that VIP pool or that VIP address is linked to an external router so that the application is reachable from the outside. So once we got that, we are ready to actually manage that cluster, use our day2 operations. We can create more instances of our target cluster. We can create more node pools in one target cluster. We can scale out the node pool. So we can add more nodes here if we wanted to and make it bigger, as long as our hardware resource is allowed to do that. One thing to keep in mind when you're scaling out horizontally is that for all the hardware resources you consume will fall. You need enough resources at the end to do an update. AKS HCI ships update roughly every month. And so once we do an update, those VMs will get replaced. So how will that happen? So the first thing we're going to do is we're going to update the KVA. So the first thing we'll deploy when your new version gets downloaded, it gets put in the download folder again. And so we create another KVA instance here, which is attached to the same VIP, but consumes its own K8 IP. So once that's done, once that's up and running, we migrate all the configuration from the old KVA to the new KVA. And when the KVA is up and running and we have determined that everything is smooth and going, we'll release that KVA, the old version, and free up the resources again. So the IP goes back to the pool and the memory and disk resources get freed again. The same thing happens in the target cluster. So first we do a rolling update, very similar to that, to all the control plane nodes. So the first thing that happens is control plane node 1 gets updated. We'll spin up a new one, update it, move the migration configuration, and then decommission the other one. It goes through all the nodes that are available. And the same happens for the target cluster. If you're just updating the OS version, your Kubernetes version stays the same. If you want to change your Kubernetes version, same process happens, but the OS version stays the same and you get a new Kubernetes version. So now that we have deployed AKS HCI, we need a way to manage this. And for that, we actually have to connect our cluster to Azure Arc. And so one thing we need to deploy here is an Arc agent. And that Arc agent connects to the Azure portal. And when we have connected our target cluster to the Azure portal, we can manage, we can monitor, we can run CI/CD jobs out of Azure into our on-prem cluster, as well as we can do to a cloud cluster. And I'll have my colleague Abhilasha walk us through that in the next demo.
Hello, everyone. I'm Abhilasha, a PM on the AKS on Azure Stack HCI team. And today I'm going to talk about how Arc helps you enable hybrid management for AKS HCI clusters. Before I start talking about it, I would like to give you a quick recap. We first saw Mike talk about the AKS HCI architecture. What are the components in AKS HCI, the prerequisites, and how do they all work together? We then saw him install the AKS HCI management cluster on top of Azure Stack HCI, and then we saw him create a target cluster. It's this target cluster that runs your deployed applications. We then saw him connect the target cluster to Arc, and in the end, we saw him deploy an application. Now, we'll see how you can use the Azure services, primarily these three Azure services, Azure Policy, Azure Defender, and Azure Monitor, for making sure that your applications and on-prem infrastructure are secure and run smoothly. Let's first take a look at Azure Policy. Azure Policy helps enforce organizational standards. If you're a part of a big organization, you have multiple teams that use Kubernetes for different reasons. But at the same time, you would like to make sure that all your Kubernetes clusters follow a set of rules defined by you as an organization. Azure Policy helps you do that. Azure Policy also provides you an aggregated view of all your Kubernetes clusters, as well as other resources such as virtual machines, networks, etc. in your organization. At the same time, it gives you the ability to drill down to a particular cluster and a particular policy and look why the compliance might be off or just further investigate any issues. Azure policies can be divided into 4 main buckets: policies that provide security, those that provide consistency, those that help you manage costs in your organization, and those that help you manage these resources. In this demo, we're going to take a look at how Azure Policy helps you drive consistency across Kubernetes clusters in your organization. Specifically, we're going to take a look at how an Azure Policy helps make sure that your AKS HCI cluster pods have specified labels. Let's take a look. To create an Azure Policy, navigate to the resource group that contains your Arc connected AKS HCI cluster, as you can see over here, and then click on Policies. As you can see on the screen, I already have a lot of Azure policies that have been created by my subscription admin to enforce on any resources and resource groups that are under the subscription. So let's go to Assign Policy and create our very own Kubernetes Azure policy. So as I was talking about the scope before, the scope determines the purview of this policy over resources. So for this demo, I've limited the scope to the subscription/resource group. So all Arc connected Kubernetes clusters under this resource group will have to adhere to the policy we're going to create now. The exclusions define if you want to exclude any resources. Even under this resource group, I'm not going to choose that. And then finally, let's come to the policy definition. So let's click on search and let's search by label. So this is the policy we're going to be creating today. Kubernetes cluster pods should use specified labels. Click on select. And then as you can see over here, the policy enforcement is enabled, and then click on next. So over here, you have to select a list of labels that you want to make sure are there on every pod that's deployed on your AKS HCI cluster. So I'm going to choose 2 labels. The first one is user, and the second one is version. Once you've defined which labels you want to make sure are present, click on save, and then you can click on review and create. Now, this policy will take about 30 minutes to be in the compliance state, and then we'll test to make sure that it works as required. As you can see over here, the policy is now in a compliance state. This means that the policy is running on all resources under this resource group. So let's go to our Kubernetes cluster and check this policy in action. So this is my YAML file that I will be applying on my Kubernetes cluster. So as you can see over here, it has a name, and I'm going to add a namespace that I've already created on my cluster, but it does not have any labels yet. So I'm going to save this, and then I'm going to go to my cluster and run kubectl apply. As you can see over here, it returns an error saying that these labels must be provided. This is exactly what I passed in my policy. So let's try adding these labels to my app and then try running it again. So I'm going to add the labels. So which are the labels they need? They need user and version. So user, and I'm going to add a version. It should now work. So let's go back and run kubectl apply again. And the pod have been created. So to check, you can run kubectl get pods in the dev namespace, and your app is running. In this demo, you created an Azure policy that ensured that all AKS HCI clusters in your organization had the same consistent behavior. And you then saw this policy in action, how it denied the creation of a pod because it did not contain the right labels that were defined by your administrator. This is one example of a built-in policy. Azure policy has many such built-in policies. Let's take a look at the documentation. This document contains a list of all the inbuilt policies that Azure Policy supports. Today, you saw this particular policy. There are many such policies like making sure that you only use allowed external IPs, making sure that you don't use privileged containers in your Kubernetes cluster, and many more. For a complete look at all the policies that are supported by Azure Policy, take a look at the first link. And the second link talks about how do you install Azure Policy on your AKS HCI cluster. Now, let's go to the second Azure service of the day, Azure Defender. Azure Defender for AKS HCI provides a complete threat assessment of your AKS HCI clusters. It also provides an aggregated view of all your resources under one subscription, be it AKS HCI clusters, AKS clusters, on-prem virtual machines, or anything else. It also provides a list of possible fixes or remediations that you can apply in order to decrease the threat level of a potential threat. Now let's go to the demo and try deploying Azure Defender on your AKS HCI cluster, and then take a look at possible threats on the Azure portal. So over here, you can see that I have my AKS HCI target cluster. It's a one Linux node target cluster. And I've got Azure Arc deployed on top of this cluster. So you can see everything is working. Now let's try deploying Azure Defender on top of this AKS HCI Arc connected cluster. To deploy Azure Defender, we will have to create a Kubernetes extension on top of this Arc connected AKS HCI cluster. To do so, run the following command. So this will create an extension of type Azure Defender. You will be creating this extension on top of an Arc connected cluster. So let's give the cluster name. This is the name of my target cluster and the cluster type, which is connected cluster. Let's also give the resource group information. And of course, a name for this Kubernetes extension that we're creating. And then I missed it's plural, not singular. So now I've finally got the extension installing. Let's come back in a few minutes and go to the Azure portal and see the Defender extension in action. So as you can see over here, I'm in the Security Center pane of the Azure portal. and I have a subscription level security center running, and it's currently assessing around 71 resources, and there are 33 security alerts. So let's take a look at this security alerts. And let's add filters based on the connected cluster resource. So let's choose filter type as resource type, and let's select only Microsoft.Kubernetes. So as you can see over here, I have a mix of sample alerts that I sort of configured for this demo, as well as real alerts that you can see over here. So let's dive into one sample alert and one real alert. So let's take a look at this alert. So it says that it has detected high privileges role in the target cluster. And it gives a description of what that is. And it basically says that, you've created a role with high privileges, and this might cause privilege escalation in the cluster, and it's unnecessary. You can take actions by clicking on this, and it tells you what you can do to mitigate the threat and how can you prevent future attacks. It also tells you how you can suppress similar threats if you as an admin decide that this is not something that is a problem in your organization. What I've found very interesting and super useful in Azure Defender is the MITRE attack tactics, which basically tell you how will the bad guys attack your cluster. So for this particular security alert, it falls under persistence, and it tells you how severe this alert is. Let's take a look at another security alert. So this is a highly severe security alert. And this is a sample security alert that I generated for this demo. So this security alert basically says that your cluster has an image that is associated with digital currency mining. The reason why this is severe is because this basically means that someone is executing something on your target cluster. So let's take a look at what the actions suggest. So let's take a look at how you would mitigate this threat. This is basically saying that you have to remove the containers that are running these pods that are doing the cryptocurrency mining. And it's also reminding you to remove the correlating deployments, replica sets, or daemon sets. So this is how you can use Azure Security Center to make sure that your clusters and your infrastructure are secure. Let's take a look at all the inbuilt threats that Azure Security Center detects for you. So this document contains a list of all the alerts for containers and Kubernetes clusters that Azure Security Center monitors for you by looking at your cluster as well as your cluster logs. So we saw some of them, like digital currency mining container detected on your AKS HCI cluster. We saw the high privilege role detected in an AKS HCI cluster. And then there are many more, like Kubernetes penetration testing tool detected, or Kubernetes events have been deleted, someone's tampering with your logs. So these are a list of all the Kubernetes alerts that Security Center monitors for you to make sure that you're following a baseline security that's required for your Kubernetes clusters. In order to ensure that every Kubernetes cluster in your organization has Azure Defender installed on it, you can create an audit policy that checks all the AKS HCI clusters in your organization and makes sure that the Defender extension is installed on it. So over here on my screen, you can see one such policy that I've created. as I've explained before, the scope of this policy is currently the specific resource group, and the effect type is audit if not exists, which basically means that it will show up as non-compliant over here if the AKS HCI target cluster does not have Azure policy installed on it. Right now it's showing up as compliance since I do have a cluster and it has Defender installed on it. In this demo, you learned more about Azure Defender and saw Azure Defender in action. You also saw how to ensure that Azure Defender is installed on all AKS HCI clusters in your organization through Azure Policy. To learn more about Azure Defender, you can take a look at the first link that points to Azure Defender's documentation, and you can get a list of all the alerts that Azure Defender monitors today on your on-prem AKS HCI clusters through the second documentation link. Now let's go to our third Azure service of the day, Azure Monitor. Azure Monitor for AKS HCI ensures that you can monitor your cluster health and performance and important metrics such as memory utilization and node CPU utilization. You can get an aggregated view of all your Kubernetes clusters and monitor them through a single control plane. Furthermore, you can also monitor your underlying Azure Stack HCI infrastructure, as well as other resources such as virtual machines deployed on top of that. In case something goes wrong and you find out about it through Azure Monitor, you can collect logs to further troubleshoot any issues. And last but not the least, Azure Monitor comes with a set of recommended alerts that you can set so that you don't have to always be monitoring your clusters 24/7. You can get an alert, say on your phone or on your email, that points you to something that's gone wrong. So on today's demo, we're going to talk more about these recommended alerts and assign something called an action group to individual alerts. Let's take a look at the demo. To set up Azure Monitor, navigate to the left-hand pane of the Azure portal and click on Insights under the monitoring blade. Once you click on Insights, it will take you to a page that says that you need to onboard Azure Monitor to your AKS HCI cluster. Click on Configure Azure Monitor and then select a log analytics workspace. A log analytics workspace is where all the data collected by Azure Monitor will be stored in Azure. Azure Monitor gives you the choice to select an existing workspace or creates a default workspace for you. And once you have your workspace, you can click on Configure. Once you click on Configure, it takes approximately around 5 minutes for Azure Monitor to be set up on your cluster. So let's check back in once Azure Monitor's set up and ready to run. As you can see over here, I've let Azure Monitor run on the cluster for approximately 6 hours. And you see how you can collect very important metrics such as node CPU utilization, memory utilization, node and pod count, and etc. using Azure Monitor. Now let's go into the second part of this demo, which is create a recommended alert. For creating a recommended alert, navigate to the top center part of the Azure portal that you see on your screen and click on recommended alerts. Once you click on recommended alerts, you can see a list of some of the recommended alerts that come inbuilt with Azure Monitor. For this demo, I'm going to select 2 recommended alerts. The first one is the failed pod count that tells you the number of pods that are in the failed state. And right now the metric is greater than 0, which basically means if there are any failed pods in your cluster, then it will send you an alert. Now you can enable this alert by sliding from disabled to enabled. And then the next important thing is assigning an action group to this alert. Now an action group helps you get a notification if that alert is triggered. So over here, as you can see on the screen, there are 2 action groups that I have. The first one is AKS HCI admins. And the second one is, your Azure Stack HCI admins. I've set this action group, I've pre-configured it before this demo. So there are 2 emails in that action group. And when this alert is triggered, both the people in this action group will get an email saying, it's from Azure Monitor, there's a failed pod in your cluster, go to the Azure Monitor, check what's wrong, collect logs, etc. To select an action group, click on select and then apply the rule. And then I'm going to follow the same process for my second alert, which is restarting container count. So anytime your container restarts, Azure Monitor is going to send an alert to you. Pretty much the same process. And click on enabled, select an action group, and you're good to go. In this demo, you saw how you can use Azure Monitor to monitor your AKS HCI cluster health and performance, as well as how you can create recommended alerts to make sure that you're always aware of what's happening with your on-prem clusters. You also assign something called an action group to these recommended alerts. You can learn more about Azure Monitor using the first link that points to the Azure Monitor documentation, as well as a how-to video published by the Azure Monitor team. This is how hybrid management of AKS HCI clusters is enabled using Azure Policy, Azure Defender, and Azure Monitor. Back to you, Mike.
All right, thank you so much. Abhilasha, this was a great demo, and it really showed how Azure Arc can really help manage your Kubernetes clusters on-prem that are deployed as AKS on Azure Stack HCI. So here's what you can do next. You can start evaluating AKS HCI. So you go to https://aka.ms/AKS HCI -eval. If you go to that website, it will ask you for a registration, and you can download the bits and pieces. You can get to the documentation. This will enable you to deploy AKS HCI on an Azure VM in a single node configuration. So no 4-node clustering, nothing of that, just single node, but you can start kicking the tires of it, and that's that. If you want to go and do that on your own, in your own environment, you can use a Windows server that you have sitting around, or get an Azure Stack HCI cluster out of the catalog and use that. If you want to learn more about it, go to https://aka.ms/AKS, and you'll guess, right? HCI docs. That's where all the documentation lives. So when you read the documentation, you can actually learn even more about what I just talked about here, dive even deeper, get more details. We also have a GitHub repo that you can find the link to in the session description on the Ignite portal. This and other links are going to be present there. We will also have a link to our learning path where you can go through the eval deployment and dive deep into AKS on Azure Stack HCI. Again, this all is going to be in the session description in the Ignite portal. Thank you very much for joining me here, and I hope to see you soon in one of the next sessions. Thank you.